Yeah, good morning all. Today we will discuss about VI characteristics of JFET. Okay, the VI characteristics of JFET is classified into two types. First one will be drain characteristics, second one will be transfer characteristics. Okay, first we will discuss about drain characteristics. Okay, to understand this one, first I need to draw the circuit diagram. Okay, this is the symbol of N channel JFET, right? Here VGG is the biasing voltage of the gate. Okay, here VDD is the biasing voltage of the drain. Okay, VDS indicates the voltage reading of drain to source voltage. Okay, this ammeter will reads drain current, this voltmeter will reads VGS voltage. Okay, now see here, first the drain characteristics are plotted between drain current versus, see here, drain current versus drain source voltage. Okay, by maintaining VGS value as constant. Okay, by maintaining VGS value as constant. Okay, step initially set VGS is equals to 0. Initially set VGS is equals to 0, right? Gradually increase the value of VDS. Okay, note down the drain current. Okay, gradually increase the drain current. Okay, note down the, sorry, gradually increase the VDS value and note down the drain current. Okay, from the graph, see here, this is the indication. Here the voltage will be VP, pinch off voltage. Okay, this voltage will be pinch off voltage. Up to this pinch off voltage, see here, the current flowing through the FET is linear. The current flowing through the FET is linear. That means if we increase the VDS value, current is also increases linearly. Current is increases linearly, right? Okay, that means it will behave as a ordinary resistor, right? That means that region is known as ohmic region. That region is known as ohmic region. Okay, after that, once it reaches the pinch off voltage from this first graph, from this, after it reaches the pinch off voltage, yeah, if we increase the VDS value, wait a minute, if we increase the VDS value, the drain current is increases very slowly, right? That is almost constant. You can observe here, the drain current is almost constant. Okay, that region is known as saturation region. That region is known as saturation region. Why? Because here because of the formation of the FET resistance RD, okay, the voltage drop will be increases, the junction will be reverse biases. Okay, when that junction will make that circuit as a reverse biases, current flowing through the device increases very slowly. That is, you can observe here. Okay, but see here, if we increase the VDS value, increases to up to certain potential, at a certain potential, the junction will be permanently break down, same as PN junction diode. The junction will be permanently break down. Then the current flowing through the FET will be increases rapidly. The current flowing through the FET increases rapidly. Similarly, repeat the above procedure for different values of VGS. See here, this is the graph for VGS is equals to 0. Next, VGS is equals to minus 1 volt, right? Again, this minus 1 volt, you will get the graph for ohmic region and saturation region and breakdown region. Similarly, VGS is equals to minus 2 volts, VGS is equals to minus 3 volts. Okay, that is about drain characteristics. Just simply you can remember, drain characteristics are drawn between VDS versus ID by maintaining VGS value as constant. Okay, if you maintain, first initially set VGS is equals to 0, increase the VDS value and note down ID value. Okay, up to pinch off voltage, if we increase the VDS value, the current flowing through the device also increases linearly. Okay, that region is known as ohmic region. Okay, beyond the pinch off voltage, okay, if we increase the VDS value also, the current flowing through the FET is increases very slowly, almost constant. That region is known as ohmic region. That is because of the presence of channel resistance, the voltage drop across the resistance. Okay, next, if we increase this VDS value above the breakdown voltage, then the current flowing through the FET is rapidly increases. Okay, hence breakdown occurs. Okay, that is about drain characteristics. Okay, next, transfer characteristics. Okay, now see here, the transfer characteristics are plotted between drain current versus gate source voltage for different values of VDS value, assume 2 volts or 3 volts, whatever it may be. Okay, set VDS value as some constant value. Okay, gradually increase the VGS value in steps. Okay, gradually increase the VGS value in steps. Note down the corresponding drain current value. Okay, that means see here from this VI characteristics, here VGS is equals to -1 volt, then what happened, current will be 7 milliamperes. VGS is equals to -2, current will be 3 milliamperes. VGS is equals to -3 volts, current will be 1 milliamperes. At a certain potential, the channel will be completely closed. The current flowing through the FET will be 0. Okay, these are the transfer characteristics. Okay, these are the transfer characteristics of a JFET. Okay, this is very important question for examination point of view. Okay, next very important question, compare JFET versus BJT. Okay, just now see here, observe here BJT. Already we know that BJT is a bipolar device, whereas JFET is a unipolar device. Okay, next BJT is a current controlled device, whereas JFET is a voltage control device. Okay, these are the symbols of transistors, NPN transistor symbol and PNP transistor symbol. Okay, here N channel JFET symbol, here P channel JFET symbol. Okay, BJT is thermally very less stable. BJT is thermally very less stable. Okay, whereas JFET is thermally more stable. Okay, the input impedance of the BJT is high, whereas the input impedance of JFET is low. Okay, but the switching speed of BJT is high, whereas switching speed of JFET is low. Okay, whereas cost of BJT is low, whereas cost of JFET is high. Okay, this BJT is connected in 3 modes, that is common emitter configuration, common base configuration and common collector configuration. Okay, whereas JFET will be configured in common source configuration, common gate configuration and common drain configuration. Okay, that is the comparison of JFET versus BJT. Okay, thank you all.